Well, you're looking
You're looking at the exit there.
You're looking at where the water comes out. The water comes out here. But you set this in the floor, and the floor is right here. And all the water goes in here. And the only place to come out is down here. So it
But
turns
you've
the
got
wheel.
your wicket gates which are here, impart an angular velocity to the water in this direction here, and that hits this blade, pushing it in that direction. Then the water drops down, and as it exits from this, it produces an additional reaction as it comes out of there. Again, so you've got a double reaction. That is a typical Francis turbine.
I spent about 3 days grinding this. Nasty work. It's such a lengthy, complicated, expensive project that it's really a very hard thing for people to come around together on. Of course, in the old days, it was different. You know, when people were making sawmills, they could cooperate. It was much easier because they would cooperate, and then it had a right to use the mill. But with electricity, it's more difficult because of the whole pattern of use and everything surrounding electricity. Well, on funding it, I borrowed the money. I borrowed the money from my father, who, praise the Lord, had the money to lend. So that's how I'm doing it, but I'm doing it as cheap as I can. I'm rebuilding old machinery and building my own machinery and doing all my own work. So I'm doing it much differently from the way other people might do it. But that's the main important thing in hydro for it to be at all viable financially. You've got to keep your costs very low, unless you're the electric company, and then you try to make your costs as high as they can be, and therefore, because your return on your investment is assured, so the more money you put in, the more you get out. But for small projects like this, you just have to keep your costs down very low.